Please welcome our panel, Scaling Your Data Pipeline for Rapid Deployment, with Jeff Mills from iMerit, Prabhdeep Singh from SambaNova Systems, and Karthik Paga from Raven Applied Technology.
I couldn't be more excited about this panel today. Both PD and Karthik bring very unique perspectives to this community because of their success in developing and scaling AI systems for many years. PD, I'd like to start with you. Robotic process automation has come a long way from concept to full production. Can you share some of the challenges and complexities you've experienced when leading these efforts at companies like UiPath as you've moved from prototype to implemented systems?
Yeah. No, thanks for having me, Jeff. This is a great forum, and I'm glad to be here discussing all these topics. Robotic process automation, if you look at the way it started as being a very rule-based system, and so it moves very logistically. And essentially, what you have is a set of activities that you can bring to fore. It's a WYSIWYG editor, pretty low-code platform. You can take a bunch of activities, be it something to pull data out of an Excel sheet, put it in Salesforce. You can combine and compose all these things together. The problem becomes most of these business workflows are pretty brittle because what if the data changes, and so now suddenly the format is incompatible, right? Or you need to do something more intelligent while you're doing this stuff. So just to give you an example, let's say you're a sales manager who is copying leads from, let's say you were at an event and you collected a bunch of leads from people who came to your booth. And now you're just copying all of that from Excel over into Salesforce. Now, you can imagine there's a lot of people who might have just walked by, which you don't want to prioritize for further engagement. So you probably need a machine learning model at that point to be able to do some basic lead scoring for you. Well, guess what? That's where you'll need to bring in a machine learning model, which essentially introduces probabilistic components inside an RPA workflow, which is inherently rule-based and logistic. And that's where the challenge comes in. Now, as for example, you have 50,000 salespeople in your company. Now you have 50,000 robots which are running with 50,000 machine learning models embedded inside them, and suddenly you have a problem because you will need to correlate a bunch of data that is coming in, making sure that the models are deployed properly. They are not making predictions that you don't want. They're working on the right data, and there's no bias in there. So looking at that whole stack, RPA hits the bottleneck when you need to do something more intelligent. And that's why there's a whole term being coined in the industry right now, which UiPath was the leader of, called hyperautomation or intelligent automation, where you start bringing in these more complex pieces into inherently logistic and brittle RPA use cases.
And I want to bring Karthik in. So Karthik, you've been at Raven for quite some time. You guys have been solving really complex challenges in the agricultural domain. I think some might underestimate how complex smart ag and farming can really be. What are the biggest pain points you're facing in scaling your data pipelines today?
Yeah, thanks for having me, Jeff. I'm super excited to be here with you and PD. Just tagging back on PD's thought around correlation. So one of the core ideas around autonomy for agriculture is being able to understand the environment in which you're operating in. And contrary to what people generally think about agriculture as a more of a structured setting, because the field is specified and you're an agent operating in a field. But here's a kicker though. Every time you go into a field, the environment changes because it is rather one of the most actively changing environments in terms of the environment itself and not necessarily other agents in the system. And the way this relates to what we do at Raven is being able to understand what are the unique circumstances in which the machine is being deployed in a field, and how does it relate with the machine learning pipeline that we have been testing with in terms of our existing test sites and whatnot. And the core value proposition that Raven has been bringing since quite a while is around being able to do the deep learning aspects online. So we have systems that are actively learning in the field, and they're adapting to the different challenges based on the changing environmental conditions, the operating you generally call them field conditions. For example, farmer A has a very different way of performing a same task versus a farmer B. But if you think of the same machine being driven exactly if the machine is developed in such a way that it needs to operate in field A and field B in exactly the same way, that is not what the farmer is buying the system for. So it really drives the need for developing a consumer-based autonomy product. And whenever you bring in consumer, the whole world of personalization kicks in from the very first second.
Yeah, it's funny how I think a lot of people would think that smart ag and farming would be an easier, more isolated use case. But I think once you get into the space itself, you find out really quickly that there's a lot of changing environmental aspects that will definitely challenge any machine learning algorithm. PD, we've got hundreds of data science professionals, listening and watching today. What best practices can you share around designing and building data pipelines? And share your thoughts. I know you're really big on the stack that you need to create to solve some of the issues Karthik was just referring to really make this scale and make your machine learning models sing.
Yeah, no, that's a really good question. And we don't have to go far in the industry to see what are the best practices, in other parts of the technology stacks, right? So if you look at, how DevOps is being handled in a typical enterprise, it's a pretty well-oiled machine, right? You have CI/CD pipelines running smoothly. As soon as you check in the code, the build is kicked off, and automatically it goes to a staging system. You run a bunch of tests, and out goes the software into production. And all this happens, pretty autonomously without any humans touching the system. Well, that's not really the case in machine learning, because if you look at, even let's take the case of, unit testing a machine learning model. It's hard because at some point, you have to take the snapshot of the data and then see, what is the objective function that you're optimizing for, and is your model becoming better based on that snapshotted data set. So DevOps in a machine learning cycle looks drastically different. And then, as we talked about, as you start scaling your machine learning models, compute becomes really, it becomes a big constraint for you. So you pretty much have to think of the stack from bottoms up, right from hardware to how you would compile the code on running these really large deep learning models and their kernels on a fully optimized hardware, then go on to provide higher level services for things like ML ops, observability, BI to quantify what is the value that you're getting out of deploying these machine learning systems, and then building industry solutions on top, as Karthik is doing. And so you need pretty much a vertically integrated stack, because all these pieces need to work together, right? If you for example, use GPUs right now, and Karthik can tell you that, if you pump a really large set of images through GPUs where you haven't allocated enough memory, you're going to run out of memory right in the training phase itself, right? And so, the thing that we're doing at SambaNova is building this vertically integrated stack where your data scientists can become much more productive, and they don't have to muck around with the internals of containerization, or actually optimizing the models, cutting the images apart into tiles, and then doing distributed inference. You don't have to do all of that, and you can just take the notebook with the PyTorch code and run it straight.
And where, PD, do you see human in the loop coming into this stack? Do you see the human in the loop layer as an important layer at the top? Like, where does that fall within the stack itself?
It is super important, right? Because human in the loop, at the end of the day, none of the machine learning models is going to be really good right out of the gate, right? When I used to sell AI solutions either at UiPath or now, that's what I tell my customers. No model is going to be 90% or 95% accurate right out of the door, unless and until you've trained it specifically on your data, and that data is like super clean. So having said that, you need to bring in the humans whenever the confidence level of these machine learning models is low. So a classic example was, we built a whole product line in UiPath called document understanding. And that was being used for, let's say, looking at health insurance claims. So a claim would come in, an OCR system would go in, digitize stuff, extract entities out of that digitized blob of text. If it did not have higher than 70% confidence on the extraction of the data, it would kick off that task to a human. And based on the feedback that you would get from the human in the loop components, that data would be collected and automatically would kick off a batch retraining process. And so that is going to be the case in almost every machine learning model, right? Whether it be autonomous cars, when you're driving around, all exceptions that you're catching as the driver is driving around is all logged in, and that is being used as the training data for the retraining of the models. So pretty much any machine learning model that you take, it has to involve that human in the loop element, and it is critical to that continuous improvement of the model.
And Karthik, you must suffer from this in basically real time as your tractors are running on fields and running into these anomalies and coming into these low confidence situations, as you mentioned, that the environment changes so rapidly in your space. Can you touch on this a bit for us as well?
Yeah, I think that's actually both hearing your discussion between PD and Jeff. One of the things I remember this scenario, I think last year or so, where we deployed a system that was meant for a specific farmer. And apparently what happened was the system was set up to operate in a specific field and actually harvest a very different crop compared to what it was actually being used for. And what we realized was not only did we have to build a system for operating in the field and doing whatever was the task it was meant to do, we also had to bring in the whole DevOps into the cab of into the other machine which the farmer was essentially commanding this autonomous tractor from. And think of it this way: whenever, as an engineer, whenever you have a new code base that you want to deploy, you would go through your DevOps pipeline and you would deploy the change, and in case something breaks, you'd have to go and fix it. This could be a test, this could be a feature, whatever it is. But now think of bringing all of that into the cab of what this farmer is using in order to use a different machine that is autonomous. So in other words, the farmer needs to understand what is error. First of all, you have to communicate to him this complex architecture, this complex vertically integrated stack that is sitting there, and put it in a form that the farmer can understand and then relate to what is happening in the real world scenario. And that would essentially trigger it would act as a trigger to our pipelines, which will capture what is happening 30 seconds before, 30 seconds after, around when the situations occurred, which should build an online data set around different trigger points, around what the farmer has indicated, and also juxtapose that with what the system actually perceived and how it has acted. And this is where we believe that human in the loop is really, really critical to actually personalize the autonomy stack and also bring in DevOps into the cab. And this is a crucial value proposition that Raven has been bringing for a while. And we've been pushing that along and seeing how do we do that for a fully autonomous system as well.
I love that because what you're really getting into here is, as your pipeline has scaled, you're starting to run into these types of real world problems, and you have to have solutions for them, as that's happening. Peter, you started to touch on this a minute ago around SambaNova. As you kind of move throughout your career, you went from kind of building a bunch of the algorithms to really starting to move into the hardware and figure out, as these things scale, you're going to need to have processing power that matches the pipeline that you're creating. Talk to us a bit about that process and about why that's so important, because I think a lot of people here today are probably maybe in the early or mid development cycle for what they're creating. But as they start getting into deep production, they're going to start needing to get into processing power issues and stuff. Would love for you to touch on that a bit, because I do think that's an area that's not touched on enough in these types of conferences.
Yeah, no, Jeff, that is a great question. And, I say that, at least personally, I'm in the business of getting people out of the POC hell. And what I mean by that is, if you look at the industry right now, 95, 96% of the people have actually tested AI in some shape or form. But if you look at the production workloads that have been deployed, it's only 16% of the enterprises that have deployed something that is in production. So there's a large swath of people, greater than 70 to 80%, who just don't know, who just don't have a path to production, right? That path to production might be hindered because of either the total cost of operation of such a system in a production setting is too high. You may not have the talent. You may not have the compute resources to be able to do that, right? There's a reason why Tesla is building its own, Dojo supercomputer, and so we need to truly democratize running and actually retraining these models at scale in production. And so that's where, when I was looking at the logical progression of where things are headed in AI, now that we have, deep learning models, they're going to be everywhere, right? They are from everywhere from your Nest thermostats to your cars to PCs, phones, you name it. And I think the bottleneck is going to be in the compute stack, right? As soon as you start putting things in production at a large scale, like I've seen, in Microsoft and Bing, how much money we had to spend to run that whole the machine learning pipeline, right? And we ended up optimizing some of the edge machines there to be able to serve stuff with a lower energy footprint, which actually optimized the cost also. So I think it's where we see the progression of these models as the models keep growing. You don't want to spend a lot of time kludging together, 16 different toolkits and the hardware, and your DevOps and MLOps platforms. And so that's where the need for this vertically integrated thing comes in, where it's a one-stop shop. You need to run a really large machine learning model in production at scale. You would need something like SambaNova.
So vertical stack plus human in the loop plus processing power starts getting us into greater scale within these pipelines. Karthik, we've seen deployment of AI across mining, agriculture. We have a lot of speakers at this event getting into the kind of truly autonomous vehicle space. Earlier we talked about people underestimating a bit about how difficult this is for farming. What role do you think the mining and agricultural AI use cases will play in helping the other autonomous mobility efforts like robo-taxis and delivery to help those go from concept to mass production?
Yeah, I think that's actually a pretty interesting question, Jeff. I was just thinking about this. So the vision that people have with self-driving cars in an urban scenario is you would get into a self-driving car, do whatever you're doing in the car, but the car would essentially drive you from point A to point B. The way mining situation and agriculture situation is different is, the person in the car or the unit that is automating a particular activity or that is autonomously operating is also going to interact actively with that autonomously operating unit. So you have a sense of shared autonomy that you're bringing into these use cases. Not only that, but also the people who are going to buy these systems, they have their own sense of what they expect from these machines. So catering to their needs and understanding what is it that you're delivering in terms of the autonomy use case, and also personalizing that for the user that is actually purchasing the system as a consumer product is really, really critical. And it becomes much more evident in the agriculture and mining use cases. And it is also very unstructured, but in a given environment. So it helps us to actively test, not only in just one city, but multiple variations within a given town or a farmland, and also customized to different farming requirements.
30 seconds or less. What is your biggest pain point or solution that you can give to our audience today?
PD, you should go first.
PD.
Oh yeah, my my value prop is pretty simple. As I said, we want to provide that vertically integrated stack to our people, who are trying to put their POCs into production in their enterprises. So what that means is everything is optimized from running on the hardware. The hardware itself is perfectly fitted for running really large deep learning models, which might come as music graphics ears, to the top level components of the stack. As I said, we have support for PyTorch, all the different toolkits, the different operators in there, state-of-the-art models like GPT, and then going on to things at a higher level for manageability and ML ops.
Karthik, last words for our audience today. If there was something that that you could share with them that you think would be helpful and you wish you had heard 4 years ago.
Yeah, for sure. I think one of the things that I was thinking was the rate at which your data organization within a smaller company or a bigger company, the rate at which your data organization grows is much, much more at an astronomical scale compared to the size of the team itself. And it is important to understand and really cater to sculpting this data organization. And the way we think about it is your culture within the organization within your team, right, within the people that you're interacting with every day, can largely influence your data organization. And the way we do it is by building visibility into our DevOps, into our entire stack. And we believe that is one way by which our culture within our teams can influence our data organization, which then flows into the customer. And when the customer buys a product, it is this culture that they're actually seeing in action.
I love it.
Yeah.
Amazing. PD, Karthik, thank you so much for joining us today. Amazing insights for our guests. Thank you so much.
Thank you, everybody. Super excited to see what you build.
Yep. Thank you for having us.